Okay, so we're going to look at when we're making graphs linear. I've got some data here of pressure versus volume, okay? And really to make mathematical models, we need it not to be so much of a curve, but more of a straight line that passes through the origin, because that way we can actually build a relationship. These linear relationships are what we're after. So first of all, if you look at this graph, you can see that actually this bottom end looks quite straight. Now this is a common issue if you don't have a large enough range, so if it's not large enough, then you can see that when you get points close together, they can look more like a straight line. Anything from this, but are you down, may seem straight. So range is very important in data collection. Next thing then, if it looks straight, we can try fit. And we can see now we've got this, even if we exclude that point, the try-fit shows us that really this is not a straight line. We can use a little bit of reasoning as well to say that it shouldn't go through the intercepts. How can we linearize this? Well, linearizing this, we can do 1 over the volume. This is an inverse, okay, so it curves away from the origin, and so it's an inverse. And what we can do is we can add in a new calculated column, boom. And within that calculated column, I've already done it over here, we can create 1 over V. So we have 1 over V, I've already done it, typed it in 1 over volume, and now I have a new calculated column in my box over here. Double clicking on the back there, I can change my axis to 1 over V, and I end up with, now, when I auto scale it, this what looks like a straight line. Best thing to do is always auto scale from 0 to make sure that we get a relative value, and then linear fit. Look at that, surprisingly enough, a 1 correlation, a perfect straight line that passes through the origin. That's a simple one when we have an inverse. A second set of data that I took was with forces, most specifically weight. Okay, and so what I did is measured force, and I plotted it against distance. When I plot those two together, I end up with this graph. Straight away, I can see this curve going back, makes me think, okay, we're in a place where we're doing an inverse. So I see this data, and I think, okay, create a calculated column of the inverse. And so I do that using my data and new calculated column, and I have it over here already. And so I can select it and change it to 1 over distance. This time I now have this, which again doesn't look very straight to me, especially when I try to auto scale it. I've got this point over here. I'll try my linear fit. I can see that this linear fit is not very good. Okay, it kind of really comes across and is way away from the origin. And so I can see when I look at it now, it's kind of going up, right? And it looks like a quadratic. And so to solve the quadratic, we have to square the axes. And so what I can do is create another calculated column where I square this distance. And now I've already done that, so let's have a look. And so now I'm going to plot my force against 1 over the distance squared. And now I look, and it looks far more linear. I can try my linear fit, and I have a straight line. Okay? So the two processes in linearizing there was if we have something that goes against or away from the origin, we use the 1 over. And then if we have something that looks like it's growing rapidly and looks like a quadratic, then we square the axes. Alternatively, if you find something that's kind of looks like it's leveling off, then we can square the vertical axes, okay? And so we can do all these little neat tricks to linearize our data so we end up with a proportionality that looks like that.